Okay, so I'm going to walk you through an example of an instance where you would use law of sines. So remember, we're talking about non-right triangles, and with law of sines, you want to have two letters of information that match each other. So let's take a look at what we have. So we set up our right triangle, A across from A, B across from B, C across from C, and then let's look at the given information we have in our example. So I'm given side length C is 12, side length A is 14, angle A is 100 degrees. Right here, I see that angle A and side length A. I have two matching letters of information, 3 pieces of information total. This is a candidate for law of sines. So we have that extended proportion for law of sines, but because the letters I'm working with are A and C, I'm just going to use these two ratios. I don't need to introduce sine of B over B. I just have sine of A over A and sine of C over C. They're equal to each other, they're proportional. So with that formula, I'm going to plug in what I know. The sine of angle A, 100 degrees, divided by 14, equals the sine of angle C over 12. And this proportion is going to allow me to find the measure of angle C. Okay, so from this proportion, we know that to solve proportions, we can cross multiply. So that's exactly what we're going to do. I'm going to cross multiply. Sine of 100 degrees times 12 should be equal to 14 times the sine of angle C, which is exactly what I have right here. Now at this point, you definitely could go to your calculator and approximate what this is, but let's actually try to keep this as an exact value until the very end, so you can see what your exact answer and your approximate answer would be. So what we've done is we've cross multiplied, and that gets us here. Now we're trying to solve for angle C, which means isolate it, get it alone on one side. That means I'm going to divide both sides of this equation by 14. And if I do that, I'm going to get the sine of angle C by itself on the right. On the left, I have this, 12 sine of 100 degrees divided by 14. And I'm still going to leave that as an exact value. I'm not going to go to my calculator and approximate just yet. Now, to figure out angle C, to find the measure of an angle, we've got to isolate it. And to do that, to solve for an angle, I actually need to use inverse trig. So I'm going to switch this up, all right? I'm going to change the statement. So now, instead of the sine of angle C, I'm going to have angle C equals sine inverse of this entire expression from the left-hand side. Angle C will equal sine inverse of 12 times sine of 100 degrees divided by 14. Now this right here, this is actually the exact value for angle C, right? But if we want to contextualize that and figure out, well, what is that approximately, you can put this whole expression in your calculator, make sure you're in degree mode, and you'll get that the sine inverse of this expression is roughly 57.6 degrees. So we've just figured out the measure of angle C. Angle C is 57.6 degrees. Now at that point, we've done the problem, we've completed it, we've solved for angle C. But keep in mind that we could actually solve for everything else in the triangle as well. So you may be asked to do that. You may see problems that say solve the triangle. And what that means is find everything that's missing. All right, so I'm actually going to take this problem a step further to show you how to do that. So let's consider what we were given. You were told that side C is 12. You were told side A is 14. You were given angle A is 100 degrees, and we just figured out an approximation for angle C. So to solve the triangle, that means we still have to find angle B and side length B. Right? And this is the point where you might go, well, how do I find two letters of information that match each other if I don't have the other one? Well, don't forget, this is a triangle, and there are 100 degrees in a triangle, right? So if we already know angle A and side length, angle A and angle C, we can get angle B just by subtracting from 180, right? Okay, so the measure of angle B would be equal to, grabbing my calculator, 180 minus 100 minus 57.6, 22.4 degrees. So nothing fancy needed there. We can get the measure of angle B. But now if you want to find side length B, we're going to come back to law of sines. So you have a choice. You can use angle A and side A, or you can use angle C and side C. I would recommend using angle A and side A simply because these are exact values, whereas this was an approximation. So if we're trying to find side length B, let's set up this proportion. Sine A over A equals sine B over B. And plug in what you know. Sine of 100 degrees over 14 equals the sine of angle B, which you just came up with because you know the triangle sum theorem, over side length B. All right, so we're going to solve for little b. So we're going to cross multiply, solve a proportion. So I know that B times the sine of 100 degrees will equal 14 sine of 22.4 degrees. And again, I'm just going to keep this exact as I go. I'm not going to approximate till the very end. We're trying to solve for B, isolate it on one side, divide both sides of this equation by sine of 100. So B equals 14 sine of 22.4 divided by the sine of 100 degrees. And from there, if you go to your calculator, figure out what this is, you can get the approximate value of B, which I have on my computer, and I need to take a look at. The length of that side would be 5.4 units. So now what we've done is we've basically solved the triangle. We have found all the missing pieces of information. And you've actually figured out everything that was missing from the figure. So that's how you can use law of sines. In a separate video, we'll do law of cosines.